Honors Algebra 2, Chapter 13, Section 3. So here are your targets for today. Looking at the 6 trig functions for any angle on the unit circle and making sure we know what reference angles are. So we're able to take a point on the coordinate plane now in which we're able to draw triangles and find the 6 trigonometric functions. So here we have the point -4, 3. So if I'm just thinking on the coordinate plane, it's already drawn for you, but again, -4, 3. So here's the point. We need to make that into a right triangle. So we draw a vertical line to the x-axis and a line to the origin, which we've known as the radius of the circle, which is our hypotenuse of the right triangle. And so then we have our measures, a distance of -4 here for the x-axis and a 3 for the y value of that point. We can use Pythagorean theorem to find our hypotenuse, which is a right triangle. So it's a 3, 4, 5. That's special right triangle, 3, 4, 5. And then we can write our ratios. So sine is going to be opposite over our hypotenuse, 3/5. Cosine is going to be -4/5. Tangent is going to be dividing y over x, so 3 over -4. Opposite over adjacent, y over x. Cosecant is reciprocal, 5/3. Secant reciprocal, -5/4. And cotangent, -4/3. So we need to make this drawing to create the triangle. A lot of this trig is really drawing your right triangle and then using your SOHCAHTOA values. Now we have something here in this. This is the angle theta. But we have another angle we're going to be discussing here in this section, which is the angle of the right triangle I actually use, this orange angle, which is actually considered the reference angle. Okay, so we can evaluate the 6 trig functions for this value of 3, -3. We can get the right triangle here, and we can know our x value is 3, our y value is -3, and we can write our trig ratios. So sine is going to be opposite over hypotenuse. We don't know that. We use Pythagorean theorem. It's going to be 9 plus 9 equals c squared. I've already squared the 3's. So we have 18 equals c squared. So c is going to be 3√2. So that's the hypotenuse. 3√2. Simplify. So sine will be the opposite -3 over hypotenuse, which is going to be 3√2. I can reduce those 3's and rationalize, and I get -√2 over 2. Which is this angle here. Then I know is at 45. And we could have saw that in our legs both being 3 and 3. Cosine is going to be -√2 over 2. I can now use some of my unit circle knowledge, knowing that these are giving the same measure. My tangent is y over x, -3 over 3, which is -1. And then cosecant, these are reciprocals. So this one's going to be just -√2. This one's going to be also -√2. And cotangent is still -1. So I'm going to have this be your video problem. Give this one a shot. Draw your right triangle, and then I'll write your ratios. So these are the key concepts that we've talked about. Unit circle we actually talked about first, that the sine of theta is y and the cosine of theta is x. That's how we've known these points as cosine sine, for mentioning that. These up here are for if you don't have a unit circle. This is for all r values. So when your r is not 1, the sine of theta is y over r. So it's using your SOHCAHTOA values. You just have to find those 3 values. You have to solve for that triangle first and then write your ratios. So we can use the unit circle to help us find some of these. So here we have the theta is 270. Theta is 270 right here. 270 degrees. Then we go all the way around here, our point 0, -1. So we just realize again it's cosine sine. So sine of theta is -1. For cosine, the value is going to be 0. And then tangent, we're going to divide y over x. Think about that. We're going to have -1 over 0, which is going to be undefined. For cosecant, we're going to do reciprocals. So this is still going to be -1. This one here is going to be undefined. And then this one here is going to be 0. So those are the values here using this point and unit circle, cosine, sine. So reference angle, we're going to be using the reference angle to solve for some of these. If we're given this theta is 5 pi thirds, so let's draw that, 5 pi thirds, where is that? Some of you might prefer me to write that as a 6 because that's how we've been using our multiples. So 5 pi thirds is equivalent to 10 pi 6. So that's past 1 pi. So we go all the way around right there, that's 6 pi 6. We had 7 pi 6, 8 pi 6, 9 pi 6, and then 10 pi 6 over here. So that would be where we're at. This would be the angle, the 5 pi thirds. So we can draw our right triangle. So we have, this is our terminal side. Draw a vertical line back to the x value, x-axis. And here's our right triangle. And so now we think about how this angle right here, what would it be? Well, if 5 pi third is all the way here, which is like 10 pi 6, how many more do I need? I need a pi third more to make it back to the 2 pi. So you know 10 pi 6 plus 2 pi 6 is going to be 2 pi, or 12 pi 6. So I have 2 pi 6 or pi third left over. This is the reference angle. The angle that you use within the triangle is the reference angle. The red is going to be actual theta value. This would actually be theta. But the black angle here that we're using, the pi thirds, this right here is the reference angle. The reference angle helps us out because now we can just use our unit circle. Pi thirds, if that's pi thirds, I already know this is square root of 3 over 2. I know this is 1/2. I know this is 1 for the unit circle. I'm not told what the actual measures are if it's more than a unit circle, but and then I can use it to find cosine, sine, and tangent, whatever I need to. But the reference angle for this is all it's asking for. So for A, the reference angle is going to be pi thirds. For negative 130, negative 130, so let's draw what that is. Negative 1, that's negative 90. Negative 180 is here, so how far past it is it? It's about 40 degrees past this. So about here. So that's negative 140. So if I draw my triangle, here's my triangle. The reference angle is the portion from my terminal side back to the x-axis. Just this blue angle is actually the reference angle, which sometimes is called theta prime. Theta prime is considered the reference angle because theta was the actual angle. So theta prime will help us find the value using the unit circle. It'll give us the same ratios as theta. If theta is negative 130, then theta prime, or the reference angle, has to be how much more do I need to get to 180, 50 degrees. So it's going to be like a 50-degree angle right here. So for B, the reference angle is going to be 50 degrees. Now that I know it's 50 degrees, I can use like a sine of 50 to figure out opposite or hypotenuse, so I can have one of those values. So we can use these reference angles to evaluate these functions. Tangent of negative 240, so this is going to be negative 180. Negative 240 is going to be up here. If I think about how draw my triangle, it's this reference angle, it's how far did negative 240 go past 180. That's the portion of this triangle we want to find for a reference angle. So this reference angle for A, the reference angle is going to be 240 minus 180, and we get 60 degrees. So now we know that's 60-degree angle, so I know that this is going to be the long side, square root of 3 over 2. This is 1/2, and this is 1 for the unit circle. So now I know that cosine of negative 240 is the same as the cosine of 60, and it's going to be square root of cosine is the x value 1/2. Now what we do need to make sure of is that our sine's right. So this is all students take calc. So sine is the only positive one, which means cosine has to be a negative. It's a negative value. You can also think about it how this is really a negative 1/2 going left on the x value. Sine of negative 240 is going to be positive. That's going to be positive square root of 3 over 2. And then for tangent of negative 240, I can divide y over x. So it's going to be the square root of 3 over 2 divided by negative 1/2. If you do that, you need to multiply by reciprocal and get negative square root of 3. So those would be the trig functions, and we can find the reciprocals. So if cosecant of 17 pi 6, so let's figure out what that is. Well, this is 12 pi 6 is 2 pi, and we need to add to that another 5 pi 6. So what we do is we're going all the way around the unit circle, that's 12 pi 6, and then we need to go further, we need to go all the way back more to 5 pi 6. So that's where we end up. Our reference angle is how much more do we need to reach back to the 180 or the pi measure, and that's going to be 5 pi 6 plus 1 pi 6 to get our whole pi. So this reference angle is going to be pi 6. So now we know our sides. This is going to be 1/2, this is 1, and then this side right here is square root of 3 over 2. This is the angle. We know the sine of 17 pi 6 is going to be equal to the opposite over hypotenuse, or just the y value 1/2. We don't care about the sine. We want a cosecant. Cosecant is reciprocal, so cosecant of 17 pi 6 is 2. So that would answer that, and the tangent for the first one is down here. So that'll be it for 13.3. Knowing how to find a reference angle, so you can use your unit circle values to evaluate the trig function, and then being able to draw it giving any point on the coordinate plane. So have a good night.